to start off. I'd like to introduce Randi Williams. She is a PhD student in the Media Lab who's really been doing pioneering work in K-12 AI literacy for children as young as kindergarten and preschool up through middle school and high school. She's been inventing a number of innovative AI technologies and curriculum, and her work is deeply motivated by passion for equity and inclusion in an increasingly AI-powered world. So Randi, please take it away. I think if you're comfortable speaking from there, that's fine. Or
great, yeah, no, I have the slides in front of me.
Terrific.
Hello, good morning, everyone. My name is Randi Williams. As Cynthia shared, I'm a PhD candidate in the Person Robots group. Cynthia is my advisor. And today I'll be sharing Sparky, which is a tool I've been working on. It's an interactive agent that supports K-12 AI education. And pretty much I'm just going to show a bunch of videos because I only have a very little bit of time.
Yeah.
I don't have a clicker, so.
Oh, I have a clicker.
Say next
Look
slide,
at this.
Oh, excellent. Perfect. So for context, the work that I do is in the field of K-12 AI education. Why? Because, in the words of one of my heroes, Bell Hooks, I think of classrooms as a radical space for reimagining the future, and in particular, the future with AI. Thinking about who gets included in designing this technology, who does not, and what would happen if more people were able to participate in the creation of these technologies. As an example, here's a student by we'll call her B, 7th grader in Massachusetts, who was learning about natural language processing, robotics, and text classification inside a course that I ran this summer. And one of the conversations that kept coming up was B is bilingual, so speaks different languages. Many students in the class did, and they kept saying that Alexa is great, but it doesn't always understand my accent, or it doesn't speak in the language that I speak in. And so B designed a doctor, because they want to be a doctor when they grow up. They think Baymax is pretty cool. Basically a Jibo doctor that was able to speak many different languages. And so the kinds of curriculum that I'm developing are where students are developing technical skills, yes, but also ethical skills, because they're working on passion projects that have very big real-world impacts. So how do we, in that space where students are working on these open-ended projects, support them in their technical skills, ethical reasoning, but also their creativity? So on the right there's some screenshots of Sparky in different forms. I'm definitely playing around and experimenting with what I want the technology to be, but in essence, it's meant to be a creative companion that learns alongside students, so less of a tutor, less of a coach, more of a tool or resource that they can pick on when they want. It provides coding and machine learning support, of course, based on this knowledge base of Scratch, which it learned, I think, from reading the whole Scratch wiki. But also it has this knowledge of AI best practices, so what makes a difference. And last, it facilitates design thinking, so it helps students think about debugging and breaking problems down. It probes their design choices and offers feedback so that they can continue to persist in their ideas. So yeah, video one, let's see it. Hopefully this works. Yes, awesome.
Sparky is a tool that provides guidance on your AI project ideas. A blank project proposal form will open.
This is one form.
Your goal is to come up with an idea for an AI project. Let's do an example. I will propose a project that helps teenagers deal with stress. First, I will fill out my project description. The box asks, what does your project do? I already know what I want my project to do. I type this project helps teenagers deal with stress. I am off to a good start, but I would like to get feedback on this idea. On the bottom right of the description text box, there is a button I can press to bring up Sparky, a chatbot I can discuss my ideas with. There are buttons I can press to have Sparky show me an example of a project description, give me some ideas, or give me feedback. I press progress check and Sparky shows a checklist of goals that I have accomplished and ones that I still need to work on. Plus Sparky gives me specific positive and negative feedback. I can also type in the chat to ask specific questions. I ask Sparky, how can I make this project more about AI? Then, I can go back and update my project description and ask Sparky again for feedback. You can work with Sparky to improve your ideas or to ask for help getting started. Look back at the progress checklist to make sure you complete all questions thoroughly.
So that's one form of Sparky, one that I've already started using in classrooms, middle school classrooms in this case. But I'm also playing around with other ideas. So here's another demo featuring some of my lab mates. This one is definitely more in the works.
Yes.
So they're working on a project where they're programming Jibo.
Hey, Jibo. Can you help me brainstorm a good idea for a
But
project?
Jibo is also using Sparky.
Sure, I'd be happy to help you brainstorm project ideas. What are some of your interests or passions that we can incorporate into your project?
We have an idea that combine panda with the peanut butter.
Of course.
Certainly. How about a project where you help a virtual panda find its favorite peanut butter treat?
So yeah, Anajali gives them some ideas.
How can I help?
They get stuck, so they head to a tutorial to try and figure out these new Jibo blocks.
How can I add a panda icon?
Add a panda icon to Jibo screen. You can use the show block from the Jibo category and select the panda icon. Here's an example.
So it helps them get through that. Then later they're training a text classifier about,
How's it
of course,
going?
peanut butter and pandas.
Can
And
you give us
they need some more
3
examples.
more words that's related to peanut butter?
Certainly. Here are 3 more words related to peanut butter. 1. Spreadable. 2. Nubby. 3. Protein rich.
So they're able to make a more robust text classifier with those additional examples. What I sort of love about this work is, this is my sort of summary slide, is that I'm thinking about different ways that this can exist, especially thinking about group work, because that's so important in the curricula that I'm building. But I think the most meaningful part of this work is actually getting to use it with students and teachers and get their feedback to reshape how this technology works. And I'll end by saying thank you so much to my collaborators, Prerna Ravi, Safiya Ali, Hal Abelson, and of course, my advisor, Cynthia. Thank you.
Great. Thank you. Awesome. So just a couple quick questions. So I know you have, again, a passion around greater diversity around STEM education and AI. As you've been doing this work, are there particular kinds of learning experiences that you think are particularly important to engage underrepresented students?
Yes. I think what I often see with the way that these technologies are spoken about is that they're for everyone and they'll make a difference in all of our lives. But when actual students start to use these technologies, they bring up pain points. And they say, well, it's great, but it kind of doesn't work in this way. And I think that's an opportunity for creation and innovation. And so can these technologies critique themselves? Is kind of like the weird question that I'm asking about them. Can they be used to actually create something better? Can the ownership of them sort of be transferred more to the people who maybe weren't included the first time around that they were designed? Sort of broad, big questions, but those are the kinds of things that come up a lot when students are using them, that they wish that it worked in a slightly different way and they wish that they could build something a little better for them.
Yeah, so maybe we can dig into that a little more deeply. I mean, Justin was calling out that maybe students don't want to talk to computers. You know, maybe they really want to talk to each other. This is obviously experience that's trying to, I think, bring both of those together. And I know you do a lot of co-design in your work, so maybe you can talk a little bit about your own process on how you dig into and refine these experiences to make sure that they're achieving the goals that you hope they will.
Yes. So what's sort of missing from these demos is the before, where students are learning about the technologies and learning how they work. Then they use them, and then they come back and they talk about and discuss and reflect on them. And then they critique them and they say, oh, but it should work like this, or oh, it should work like that. And I'm like, awesome, let's build it. Like, how do we do that? And so the co-design process very much looks like presenting a prototype that is something that's transparent. They can break apart, put back together in different ways, and sort of frames the technology in a way where it's something that we're all tinkering on together, as opposed to something that they just have to use in the form that it exists. And I think that's particularly powerful for the educators, because they're often being told that their students using these technologies and they have to do something about it, or they have to use these technologies and there's training next week. Can we also give educators the opportunity to critique and build and think about how they want to bring them into their classrooms and integrate them with their own teaching practices? That's something that I'm able to do in my work, because smaller classes, I'm not changing whole systems yet, but I think what we learn from that can be very powerful looking at broader scales.
Great, thank you so much. All right.
Thank you.
Next, we have Jesse Thaler, who is a professor in the MIT Physics Department. He's also the director of the NSF Institute for Artificial Intelligence and Fundamental Interactions.
Wow.
He's been doing a lot of innovative work at the intersection of generative AI and physics education and outreach. Jesse.
Right, well, Thanks so much. Yes. Thanks so much for having me. And good morning, everyone. And this is a very, very unfamiliar learning environment for me. I'm a theoretical physicist. I'm most at home with a piece of chalk and a chalkboard. I was very skeptical about the power of AI in my own research field. But my mind changed, in part because of interaction with graduate students who were teaching me the way that computing can affect the research that we're doing, and then also, of course, affecting the way that we can do education. So I'm the director of this Institute for Artificial Intelligence and Fundamental Interactions. If you haven't heard of us, it's because we started during the pandemic in 2020, but we're a joint effort between MIT, Harvard, Northeastern, and Tufts. And what we're trying to do is fuse kind of the advances in deep learning with the kind of deep thinking that we do in fundamental physics, the principles that govern our universe, to gain both a deeper understanding of how the universe works, but also a deeper understanding of the way that intelligence works. And you can think about certain AI systems as complex physical phenomena that have emergent behavior, and actually thinking about AI through that scientific lens has been very helpful in our research. So we have research that's at the intersection of AI and physics. We're also empowering the next generation of talent through various educational efforts that I'll talk about in a moment, as well as building a community. And part of the way that we've got into generative AI has been in our engagement with the community. So let me just start on the research end. Generative AI, that phrase has a very rigorous meaning in terms of sampling from probability densities. And generative AI has been absolutely transformative and will continue to be transformative for scientific discovery. So within IFI, we're using generative models to actually create digital twins of our universe and studying astrophysics and cosmology by generating synthetic data sets about the distribution of galaxies in our universe. And then generative AI, it turns out to be a strategy for doing first principles calculations of the structure of fundamental matter. And in nuclear and particle physics, we're using generative AI in a very different context than synthetic image generation. Rather, we're generating synthetic gauge field configurations for quantum field theory. Yet the mathematics behind that is actually relatively similar, though the technologies behind them actually have to be quite different because of that differing scientific application. And what we can do is now take these generative AI developments that are happening in the research sphere and bring them into the education sphere. And my colleague Phil Harris in the physics department has developed a course that's both available on MITx, but is also part of the MIT course catalog as 816, where we're actually bringing data science into physics, where we have, for modules 1, 2, and 3, more traditional data science and machine learning. And then module 4 is actually based on what I told you about first principles calculations in nuclear and particle physics, where the same type of generative AI that's at the forefront on the research is now being brought into the classroom. And in general, this intersection between physics, statistics, data science is very rich, and we're proud to partner with the MIT Statistics and Data Science Center to bring an interdisciplinary PhD program to our MIT students. Now, when we're thinking about generative AI, I just talked about generative AI in the kind of rigorous sense, something you can actually use for scientific discovery. What about in the more kind of creative space, image generation, text generation? And we've been working with the Cambridge Science Festival. We had 2 events that happened this past September. One was a lunch and learn about ethics and AI and art, where we talked about the science behind generative AI, but then also the ethical implications. And then at the carnival, there was a chatbot, which you'll be able to play with in the hallway out there. That was actually started off as an April Fool's joke. So my name is Jesse Thaler, and you've heard of ChatGPT, but have you heard of ChatJessieT? You can go to chatjessieT.com. And as a kind of April Fool send-up, they did fine-tuning of, I think it was of GPT-4, in order to make it know all of the papers that I've ever written, my website, my Wikipedia page. Wow. And it responds very enthusiastically about topics in physics and AI, and it is a pleasure to use. But it's kind of a joke. Of course, it's a fun joke. And when we saw people engaging with ChatJessieT and the type of questions that it would be asked, we realized that actually we could go one step further. And instead of taking a scientist like myself, how about taking a historical figure who's very important? And that thus was born Oppenheimer. So it was an April Fool's send-up, but then a public engagement opportunity. And this is an example of a query you can do. You can ask like kind of fun things to Oppenheimer and ask, telling a joke. This joke, let me see if I can read it. A neutron walks into a bar and says to the bartender, "How much for a drink?" And the bartender replies, "For you, no charge." Okay? But because this is Oppenheimer, the neutron, feeling quite pleased, says, now I have become debt, destroyer of wallets. Okay, so you have this kind of creative engagement. And now you think about how you're going to bring this into the learning space. And so our i5 project manager, who wanted to learn something about physics, she herself comes from the academic publishing world, knows basically nothing about physics, but she heard me and my students talk about the Born-Oppenheimer approximation. So maybe the virtual Oppenheimer should be able to answer what the Born-Oppenheimer approximation is. And so she asked the question, and it responds. It's a simplification of the mathematical treatment of molecules in quantum mechanics. That is correct. Then it gives a list of 3 papers. The first one exists. The second one does not. And the third one is not really appropriate for a research context. And this, for me, was a little bit disappointing because we had actually trained this on a bibliography of all of Oppenheimer's works. And then me looking back and seeing the failures of that bibliography, actually, the bibliographic entries were actually missing for the papers that should have been there. I mean, indeed, the original first paper actually is not in the database that was used for searching, which is a failure of kind of the information behind it. So, in thinking about bringing GenAI into the education space, there's a couple of things that I think about. One is that, we teach every student 2 semesters of physics because physics provides a universal language that can be applied to a range of scientific problems. But similarly, I believe that statistics, data science, computation, it offers a similar universal language, and that needs to be brought very much into the education space. Now, generative AI in this rigorous sense offers new pathways through the physics curriculum. We start with calculus. We start with mechanics and electricity and magnetism. But if students become more versed in probability and statistics, we have an opportunity to introduce them to quantum mechanics and stat mech much earlier on in the curriculum, so that's an interesting opportunity. But then in this more creative sense, there are new learning opportunities, which I'm happy to tell you about, and also just a further advertisement for i5 that we're trying to build this common language that transcends the intellectual borders, because there's actually a lot of intellectual similarities between what we're doing in the physics space and what's going on in the AI community. Thank you.
Great, thank you. So Jesse, you've talked about hallucinations. Yeah. And in our back and forth, you also mentioned, in primary school, students first learn to read before they can read to learn. So what do you think students really need to know about generative AI to be able to use it as an effective learning tool for themselves?
So there's 2 things. One, which is an unfortunate design choice that is actually easily solvable, that there was nothing stopping Oppenheimer from actually giving links to the primary source material. And the first thing is that we are hyperlinked up the wazoo. Why are we not hyperlinked up the wazoo in the kind of generative space? Why is there not everything clickable to say where are things coming from? Where is that information coming from? And so understanding the connection to primary source material and actually the joy of discovering, digging down into the literature and finding opportunities in literature, that's one thing that I think we can do and that students kind of need to learn. Yeah. And the other thing that not only students need to learn, but we all need to learn, and as a physicist, this is very natural to me, but it turns out to be not so natural to other people that I talk to, which is that generative AI is not a deterministic computing tool. It's not a calculator that every time you do 3 + 3, you always get 9. It's a probabilistic distribution. And of course it is. It's generative. That's the definition of generative modeling. It's like probability distributions. But somehow we don't understand that. We don't understand that this is a complex emergent behavior. And that's something that it turns out I find surprising that someone will only ask a question once or only generate an image once and not think about, well, what if I generated thousands of images of peanut butters and pandas? What would the distribution of that look like? And understanding that kind of more distributional probabilistic thing I think would be helpful. And this is a sea change that hopefully will happen in education away from calculus-based only deterministic things to more probability, statsy ways of engaging with education.
Great. Thank you so much. All right. Nice. So next, often students are the lead innovators and power users of these technologies to advance their own learning. So our next speakers, Rachael Harkavy is a graduate student at MIT Sloan School of Management, and David Koplow is an MIT senior and co-presidents of the HK and Honor Society. And we really wanted them to be on the panel to share their perspective as students and how they're using generative AI in their learning process and what we can learn from them in that. So maybe start with you, Rachael.
Yeah, absolutely. Thank you for having me here today. Very excited to get a chance to kind of talk about my experience as a student. I don't have anything as exciting as Sparky or JustCPT to talk to you all about, but I can talk about what the transition was like coming from working in a tech startup back to school. So I'm a dual degree student in MIT Sloan and the School of Engineering and Computer Science. And the difference between those two is apparent in a lot of ways, but everyone is using ChatGPT. And I think that was the most surprising thing for me coming back to school. We had just started using it in my startup to kind of work on, getting personalized content to members, et cetera. But I wasn't expecting to come back to school and have the landscape be completely changed from when I was an undergrad. So assignments as an undergrad that I would dread, that would take me 2-3 hours of writing, all of a sudden, ask ChatGPT, edit it into your own words, 25 minutes. And so I've really been struggling with some of the ethical implications. As a grad student, I came back to school to further my own learning. I'm not here because anyone's making me be here. This is something I'm paying for out of pocket. So having a tool like ChatGPT available and then figuring out how to use it to not take away from your own learning has been really challenging for me. In things that I'm more confident in, like coding, I love using it. I love using it as a debugger. I know how to code. I don't need any help. But starting in my MBA classes, using it to read cases, probably something I should be able to do on my own without ChatGPT. And so it's been a really interesting balance for me trying to figure out, as an adult, where that line is. And I think the things that I've been thinking about have been, how does that look for middle school students or high school students who maybe don't have the same learning goals that I do if I'm struggling with it as a 26-year-old? So really excited to be here today and listen to everyone in the field of computer science, education, physics, talk about their experiences and kind of helping myself to untangle what that looks like.
Great, thank you. And David, can you share your experiences? Yeah.
Sure. So my name is David Koplow. I am the co-president of HKN Honor Society. I am also the co-president of AI at MIT, which is MIT's largest AI student organization. But perhaps what's most important for my experience today is that I'm a senior, one who might be taking what might be my final exam in 23 days. So it's a little bit surreal for me to be up here speaking to all of you, so close to the end of my foreseeable academic journey, about AI and how it can be used to aid a student's education, especially considering that I might not be at MIT today if it weren't for this technology. You see, I'm dyslexic, and this conversation, this realization that a lot of people are having over the course of the past year with using these large language models to help promote their learning and access material in a different way is similar to a realization that I had about a decade ago when I started using text-to-speech software. And it kind of meant that overnight, I was no longer limited by my speed of reading. I was limited by my speed of understanding. And it allowed me to really pursue and dive deeply into the things that I excelled at, the things that I loved, and really just go forward with that. And well, in parallel, I tried to improve my reading ability and all the other things associated with dyslexia. I knew that I would never be at that same level as many of the other people, probably in this room. And that was okay, because I would always be interacting with the world through these tools that allowed me to interact in the world in a way that I had more power and the way that I was more effective. And what I see happening right now is a similar transformation. Now, there are some that are worried about these large language models replacing entirely the role of what a student could be. And there was a paper widely spread over the summer that claimed MIT could, or GPT-4 could ace MIT's Zeek's curriculum. And I think that's like an example of people really pushing, like jumping the gun here in that sense. That paper turned out not to be totally accurate, but it's very clear that these large language models are radically transforming what the role is of being a student. And I think, given my experience, this should all be addressed in the form of what is the purpose of what we are learning? And how can we use these large language models in ways to better get to that purpose? And that might mean that we don't need to learn some things that we used to learn or not as deeply. So for example, maybe it's not as important to learn SQL very deeply as long as you have a working understanding of how to code now. Because what becomes more important now is the ability to determine when something is wrong and how to fix it, not to generate something from scratch. And I'm really excited for all the ways that this is starting to take place in academia and all the ways that it's going to be changing the world of education in the coming years.
Great, thank you so much. All right. So I have a question for both of you, which is, given all the experience and using these tools and using it to further your learning, what do you most want educators to know about how to harness these things from their side to further their ability to help you learn more effectively with these tools as well?
So I guess I can go first. I think that these tools should be really embraced, and that educators should be looking at ways to use these tools and even refine what they're choosing to teach in the context of these tools. These are tools that all of your students will have access to for the rest of their lives. And so it's important to be asking always the question with everything that you're teaching, why are you teaching this? And how can, going forward, like maybe there's another way to teach it or another thing that you weren't able to cover in the original class that you can now start talking about because you're able to move through material more quickly because students have access to these tools.
Yeah, I think from my perspective, it's clarity of expectations. So is this a class where you want us to be using generative AI to help us with our homework? I've had professors that have ChatGPT policies that is just use it, period. And that's really helpful because that shows that they're thinking about it and they understand students will be using it. And so hopefully they're designing their lessons and their assignments with that in mind in a way that ChatGPT isn't doing all of the work for you. So I find that if teachers have done the thinking around how to use it as a tool ahead of time, it's incredibly helpful for the student to then know where the boundary is of, yeah, summarize that reading. This is not an exercise on reading comprehension. This is an exercise on then writing the essay from it. And so if a teacher tells you that up front, it's a lot easier for you to go do your homework and say, okay, whatever, I don't need to read that article. Instead, I'm going to focus on this summary, make sure it's correct from the reading, and then I can write my paper. And so that's been by far the most useful thing for me.
Great, thank you so much. All right. All right, we also now have Anajali Sastry. She's a faculty director of the Breazeal World Education Lab and associate dean for open learning. She's also a senior lecturer at Sloan, and she brings a global workforce perspective, particularly when you think about developing countries.
Hi.
Yes.
Thank you. So you just mentioned, I don't need it.
Okay,
I don't
great.
have
Okay.
slides.
All right.
You just mentioned thinking about your students, and part of my job is to think about the world's students. So the Breazeal World Education Lab connects ideas from MIT, a community that's anchored at MIT that has a relationship to MIT with educators all over the world. And we probably have 1.5 million, this is my guess, students who are at our collaborating institutions, and well over 100,000 faculty alone, not to mention staff, postdocs, TAs, et cetera. So we have a potential for massive reach. What we often do is work directly in a sort of go the business route, B2B model, working with the universities to help them innovate, address challenges, come up with new ideas for how they arrange their curricula and their learning experiences, student experience. For instance, all around the world, first-year learning could really stand to be improved at many universities. We see high dropout rates. We see students struggling to kind of understand and onboard into universities, especially when they come from varied backgrounds. All over the world, too, universities are being asked to innovate and serve society in new ways. So a great graduate who's ready for the work world, new research, but are we actually also improving our environment and our community? And that's putting some really interesting new educational ideas that have a long tradition at MIT into the mix. Can we do real-world projects, for instance, that get students tackling problems and challenges that they see right in front of them? How could AI help with all these things? So our university partners ask us they are hungry for knowledge about how do instructors adapt their current assignments to address AI, or could we get a quick course so we can understand better what this is? what are the MIT tools that exist to help us bring AI, MIT-level AI teaching directly to our students. And we also experiment at J-WEL with working directly with doing teaching ourselves. So we're not all B2B. One of our flagship projects, efforts, is now 6 years old, built on an earlier program that's still informing this effort called React. Our emerging talent program serves refugees, internally displaced people, migrants, and others who lack access to formal education. And it's a really interesting use case for AI because students come into that wanting a ton. We have massive excess demand for taking some MIT courses and getting an MIT certificate, and then learning a bit about the work world, how to position what they're learning with respect to jobs. And this is clearly one opportunity that everyone would love to think more about. How could we pair education with a pathway into a job? And it's become very controversial. So I'm going to give you your quote of the week to remember. I wrote it down. Both Texas and Mississippi are pushing universities to spend, they're trying to use funding as a mechanism to push universities to encourage students to do useful majors, right? And with the advent of AI and sort of monitoring and managing what students are doing, you could see mechanisms for recommendation and pathway mapping becoming ever stronger in terms of shaping choices that students make. And the quote of the week is, we need to get rid of useless degrees in garbage fields. So what are the useless degrees? What are the garbage fields, right? And what do we lose when we say those things should not exist? So I think there's a moment here to bring back into the conversation the theme we've already been hearing about. How do we link humanities? How do we link critical thinking? How do we link teamwork? And essential skills of discernment, of debate, of resolving complex and breaking down complex issues. How do we bring them into the mix? I think I'm very much in keeping with what others have said there. But done well, you could imagine an AI watching a student and say, hey, do you realize you're really good at this? Try this course next. Or it looks like you're really stuck here. Let me help you out with this additional reading. So you could have tutors that are responsive, where a student would inquire, or you could have tutors that are sort of monitoring and guiding. And we know that navigating, even here at MIT, we have a wealth of courses. How do you figure out which course to take? Or if you are a self-directed learner and you open the door to OCW, how do you know where to go? Because there's so much there. Guidance could be really helpful. And guidance that you have some faith in could be fantastic. You could imagine then using that method to think of new ways we could deliver education at scale. What if adults in the workforce could take small courses and get some real-world project experience that was calibrated nicely to the course that they were taking, and then bundle that together into a credential that would allow them to do sort of episodic learning that link to interests and perhaps market demands or real-world opportunities, and accumulate portfolios of qualifications that went beyond classroom learning or MOOC learning and included real-world engagement. And we're actually experimenting with exactly such things in our emerging talent program. I wrote 9 more ideas down, but I know we don't have time for all of them. But I do want to put in a pitch for a form of, for thinking about inclusion in a way that I think really will change the world for the better for all of us. So one challenge we have is we're looking at tools and needs that we have even within our team. It's very tempting for folks who are supporting us to say, you have a small program, there's much bigger programs here. So we're going to focus on the bigger programs and make sure we're meeting their needs. It seems like a very rational decision. But if we're not working at the edges and serving students from extreme conditions, maybe someone who would never make it to MIT, how are we then testing our knowledge? How are we building the most robust possible platform and the best possible learning routes for people? So I'd urge us to look for edge cases and to look at ways in which we can work with the students that we're already serving through J-WEL in Tanzania or in Uzbekistan or in Latvia or in Mexico or in Indonesia or in India. So we have probably 24 organizations all over the world we work with. But just think of what we could accomplish if we could tap into all of them and really take their student experiences and their faculty ideas seriously.
Great, thank you. All right. I'll ask one question, maybe as Anajali answers it. If anyone from the audience wants to approach the microphones, we can take a couple questions from the audience as well. So Anajali, if generative AI were actually able to deliver this revolution in digital learning and teaching that we aspire to, is that going to get us far enough towards enabling opportunity for all?
So I've been thinking about this question a lot, as Cynthia knows, because again, our own experience is showing us what the challenges are. So I read a recent UN report that argued that if we wanted to get all of the world's learners online with easy access, devices, and internet availability, it would cost $1 billion a day. So I don't know if that's true, but it's in a recent report. So there's still the issue of access to data, like as in minutes of data, connectivity to the internet, access to the devices. We do know that we have to design for mobile phone-based applications, but we also know that mobile phones limit the kinds of information and immersion that's possible. So I think access is going to be a huge issue. Just making great AI tutor tools is not going to get us far enough.
Yeah. Great. Yep. Thank you.
Sorry, it's not good news. Sorry.
We're here to unearth the reality. Are there any questions from the audience? Okay. Maybe if we can hand the mic over. Somebody can grab the mic.
Oh. Yeah, it's right there.
Oh, here we go. Yeah.
Okay.
All right. So
Great.
there's a couple of questions that I think I want to just throw out to the team. I think, in my mind, is as this thing gets smarter and smarter, and it will be smarter than the entire human race, I'm thinking about how are we going to be able to control it. And what comes to my mind, it's MIT, we're like the best in the world in being able to build, I went to MIT, so like best in the world to be able to build technology that we can allow us to be able to do that. And, 20 years ago, I was building AI that was controlling the black boxes trading in the stock exchange. And if they went sideways, we shut them down. So we should be building some newer technology that helps us to be able to shut these things down if they go sideways. And maybe have some other AI that comes and monitors those things. And I was wondering if, number one, if somebody is working on that problem, because that's going to be a problem that's going to hit us, and it's going to hit everybody in the entire planet, right? Just like COVID did. And if we don't come up with, we don't put the smartest people in the world to work on these problems, it's not going to get solved. So that's, number one thing that I would love to be able to ask if anybody's even thinking about that, or coming up with solutions for those things. And the next thing is, you mentioned something about, having hallucinations. And, we've solved this problem in AI before, where we asked 10 experts, what's the problem? And then 9 out of 10 disagree or agree on something. And then we pick the one that, the one that does the most. So maybe we use 8 or 9 generative AI things that we ask it, and we filter out a lot of the noise. So we can actually, so if there's some research that's working on that piece to be able to solve those problems, because we see the patterns already of what we've done before. And so I just want to ask some of those open questions and have the team come up with some comments on those things. Thank you. Great,
thank you. Maybe Jesse, I'll have you field that one.
Yeah, so I come from the world of curiosity-driven research, and so the fears that I would have are related to things like data falsification, giving the wrong person a Nobel Prize, and
Not to mention any names.
Right. But you know, one of the things, I mean, you mentioned kind of AI monitoring other AI. Like at least in information space, provenance seems to be something that's really important and lacking. And so I mentioned before kind of the ability to hyperlink everything. Understanding where the information is coming from is essential. And I'm gonna get the quote wrong from Einstein, but you know, was talking about like all these scientists, the majority of scientists attacking his work. And Einstein said something like, all you needed was one person, you know, if I was actually wrong. And so just a majority rules is not a good strategy for safety. Rather, you really need to have provenance. You really need to have, you know, logical inquiry. And that's something that I think we need to be building in much more into our tools.
Great, thank you. I think we're actually at time. Let's thank the panel. I know.
Thank you.
I know.